Alright, for section 7.3, day 1, going to run through the process of what the book calls row echelon form, or solving using row echelon form, or what we'll eventually be calling using Gaussian elimination. And it's a little bit different than what we did last year, and it's going to take some time to kind of get used to it. And just to kind of remind you why we're doing it, when we get to chapter 8 and we're working with matrices, we'll have to be able to solve this way, so it's nice if we can get this rhythm down. So I'm going to try to show every single step that I would do. Some of the steps we'll be able to combine. I've got 3 problems I want to do. This is the first one, solving. And again, I'll run through all the steps for you. Second one will look something like this. And again, I'll show you all the steps, and then I'll show you maybe what steps I might combine, what steps I wouldn't combine. And then the last one will be a story problem where we will have to come up with the equations kind of like we did in 7.2 and then try to solve it from there. So it's a process that's going to take you a second or two to get used to it, but once you get it down, it's usually not that bad. There's a lot of room for little mistakes, so you just have to be careful. So if you look back at your notes and you look at when you're trying to solve one of these, you have a certain set of steps that you're supposed to do. And step 1 says you want the first equation to have a 1x in front of it. Well, it obviously doesn't. I could divide all these by 2, but I don't want to introduce fractions if I don't have to. There's times where you have to, you have no choice. But remember, one of the rules said I could take this equation and this equation and have them switch places. So I'm going to do that. I'm going to write the third equation as if it's the first equation, because that is one of our properties. It allows us to interchange equations. So now it's x plus 4y plus z equals 0. I'm going to keep the 2x minus 4y plus 2z equals negative 6 in the middle. If I want to, I could rearrange the whole thing. I can interchange equations, so it doesn't matter how many I interchange. And then the one that was on top, I'm going to put on bottom. So it's now 2x plus 4y minus z is equal to 7. And this is the step that I said on the homework. If this problem is written down when you're doing your homework, you don't need to copy this down and then do this. You can just do the first step right away. Now remember, I want you to kind of make a note of what you're doing, because this can be very hard to follow. So what did I do? Well, I took row 3 and moved it up here to row 1. So I'm just going to say that this was row 3 on the previous step. This was row 1 on the previous step. So when I look at this, I can see all you did is you switched these two. Alright, so there's step 1. Get a 1 in front of that x position. Step 2 says to get rid of these x's. So I don't really care what's going on over here. I don't care if this says z equals 2 and you already know what z is. It's not. The process that we're going through doing this row echelon form isn't necessarily about the solving. Yes, obviously we're trying to solve, but the important part is to get the process down, so that when we're working with matrices and they ask us to find the inverse or solve or do something like that, that we know what the process is. So although yes, you do want to solve, that's really not what we're trying to get right now. We're trying to get the process down. So okay, back to this. I got the 1 in front. Now I want to get rid of these 2. So please put the box around each step. It makes it very easy for me to follow. So when you do this, I prefer that you go down if you can instead of to the right. It's up to you. Just draw an arrow. Just make sure that you're showing your work neatly. Alright, so I'm going to copy that first equation. Once I get the 1 in front of it, every step after this, that equation will not change. The second equation, well, I'm going to do a combination of things. I'm going to multiply the top equation by negative 2 and add it to that one. So I'm going to multiply row 1 by negative 2 and add it to row 2. Again, this is just a clue or telling me what is it that you're doing. Remember that when you're making a note, row 1 is referring to row 1 on the previous step, not the original. Alright, so now I'm going to do this in my head. Negative 2 times 1 is going to give me negative 2 plus 2. That's going to give me a 0. You don't need to write anything there. Negative 2 times 4 is going to give me negative 8 plus a negative 4, or negative 12y. That's going to give me negative 2z plus 2z, or 0z. You don't have to write anything. And then that'll give me 0 if I multiply by negative 2 plus a negative 6, so negative 6. Now again, that's wonderful that we know what y is, but that's really not what's important. If there was a number here, I'm still going to do everything exactly the same. Now I need to get rid of this 2x. So if I multiply this by negative 2, add it to this one, it'll make that a 0. So I'm going to again make note of what I'm doing. It's negative 2 times row 1 plus row 3. And the only reason I want to see this is if you make a mistake, I have to be able to identify what you're multiplying by what to be able to get these numbers. Now, if you're afraid of making a little mistake doing this stuff in your head, you're more than welcome to, on the side, show your work. So, for example, negative 2 times row 1. You can say this is negative 2x minus 8y minus 2z is equal to 0, plus row 3, which is 2x plus 4y minus z is equal to 7, and you can add them together and say, okay, that's going to give me negative 4y, that's going to give me negative 3z, and that's going to give me 7. And you'll see that this is going to be in here. Now I'm going to do it without showing the work and see that it's the same thing. It's just if you feel like you're going to make little mistakes, you can do this. It's a little bit more time consuming, and then it eats up a lot of space. Like I said, you have to be very neat. If you're going to show this work, I want it to be right next to this step. So I would show it for here, and then I would show another one for that equation possibly. If you're going to the right, then show it underneath it. Just make sure it's neat and organized, because if it's scattered all over the place, it makes this very, very hard to grade. Alright, so now let's pretend like I didn't have this. If I multiply this by negative 2, add it to 2, that gives me 0. Multiplying by negative 2 makes it negative 8 plus 4 would give me negative 4y, which of course I had. Negative 2 minus 1, so negative 3z, which of course we had, is equal to still 0 plus 7. So I get the same thing, it's just you're less likely to make mistakes if you actually write it out. I'm not going to do this, but if you feel like doing that, you're more than welcome to. Alright, so goal 1, if you will, is accomplished. I have a 1 in front of that x, and I have nothing underneath it, or I have zeros in front of those x's. That's what my first 1 or 2 steps is. After that is accomplished, my next goal would be to get a 1 in front of one of those y's. Whichever one is easiest to do. Now, a lot of times what you want to do is try to do some sort of multiplying combinations, but I noticed that 4 goes into 12, so the easiest thing, or the only thing I can really do, is divide. I either divide this equation by negative 4 or that equation by 12. It looks like that one would be easier. So remember, you're still writing down the first equation. You should have 3 equations for every single one of these steps. And most likely you're going to have 4 to 6 steps for most of your problems. It just depends. Alright, so what am I doing? Well, I'm either dividing by negative 12 or I'm multiplying by negative 1/12. So again, tell me what you're doing. I'm taking the second row and I'm just multiplying it by negative 1/12. That's 0, so it's still 0. Multiply by negative 1/12 will make it 1y. That's still going to be 0. Equals negative 1/12 will give me positive 1/2. And now you've accomplished the goal. You've got the 1x, you've now diagonally got the 1y, and then of course the goal will be get to 1z. Now I'm just going to leave the third equation alone. My goal was on step 3, when you look at the actual steps that we had written down, step 3's goal was to get the 1 in front of one of those y's. Step 4's goal is to now get rid of that y term, because you want to have 1x, 1y, 1z, and then zeros here. So this has got to go next before I worry about that z. Alright, so how do I do that? Well, again, write down the top equation. That one's not going to change. Now that I have a 1 in front of that y, that second equation is also not going to change. And think about what it is you're doing. You're going to multiply the second equation by 4, add it to the third equation. So 4 times row 2 plus row 3. Like I said, this is a little weird and goofy, and it's something that it takes a little time, but once you get it down, it's really not that difficult. Everyone seems to always understand what they're doing. It's just easy to make a little mistake is all. Alright, so negative 4 plus 4, of course that gives me 0. Multiplying that by 4 is still going to be 0. Adding a negative 3 gives me negative 3z is equal to, multiplying that by 4 is going to give me 2 plus 7, which is going to give me 9. And then realistically what you should be doing is do a whole nother step, which I know you don't like writing all this out. Like I said, it's the process. Just get used to doing it. My last thing, I would divide everything by negative 3 or multiply by negative 1/3, and that would give you 1z is equal to, looks like it would end up being negative 3. And then once you have the 1's on the main diagonal and zeros here, then you know you're done. But the process has to go in this order. Get a 1 in front of one of those x's and then put it on top. Get rid of the other two x's. Get a 1 in front of one of those y's and then put it on top or in the second position. Get rid of the other y and then get a 1 in front of that z. It has to be that order. Don't try to do anything else. Now, I said if you don't want to have to write this whole thing out again, what you can do instead is, since all that's going to happen is you're going to divide by -3, you can just arrow to the right and say, okay, I know z is going to equal -3. That's what I would have written here. I'm just not going to write the whole set of equations again to do it, but realistically that's what you should do, and we will do it eventually. Alright, so that's solving using Gaussian elimination, or the book calls it row echelon form right now. Now we haven't technically solved. All we've gotten is that stair-step pattern that we looked for. Now obviously I can see that z is equal to -3. What you would then do is go back to the second equation and plug z in. Well, there isn't a z there, but if there were, I would plug it in and solve for y. Well, I get pretty lucky. I can see that y is equal to 1/2. So there's no work to show for that. Typically you would have to show it. And now I'm going to take both of those and plug it into the top equation. So I have x plus 4 times y, which I know is 1/2, plus z, which is really -3, equals 0. And so now I just have to calculate and say it's 4 plus 2 minus 3, that's -1, add 1 to the other side, and there's my x value. And now my answer is x, y, z. And there is my point. So it's going to take some getting used to, so if you're not 100% comfortable with it, that's fine. That's why we're spending 2 days on it. The second day we're not learning a whole lot of new things, it's just getting some extra practice with it. So just keep doing the practice. Most people actually like this section. It's just easy to make a small mistake. So, alright, on to the second one. Alright, so I'm going to go through those same steps again, and I'm going to kind of combine a couple of them together just to kind of speed things up. So when I look at the problem, of course the first thing I do is I glance at these and say I need a 1 in front of one of those x's. I'm lucky I already have it. So I don't have to do anything there. The second step, which I would kind of combine, is I need to now get rid of these two. So when I write my problem or my steps down, it's x plus 2z is equal to 5. I'm not going to change that first equation anymore. And then I'm going to multiply the top equation by -3 and add it to the second row. So multiply by -3, add it to this, that would give me the 0. I'm going to multiply by -6, add it to the bottom row. So -6 times row 1 plus row 3. And again, this is there for me, so if you do have something off, I can see what it was that you did. Otherwise, if you don't write that, I'm not 100% sure what you're doing. And if I have to spend a minute or two trying to figure out what you're doing, it just makes things much more difficult, so please do that. Alright, so again, control your work to the side if you prefer to do that. So I've got -3 plus 3, that's going to give me 0. Of course I did that for a reason. Now there is no y term, so it's still going to be 0 when I multiply by -3 minus 1, so this would be -y. That will become -6, because remember we're multiplying by -3, plus a -1, so -7z is equal to -15 plus 1, or -14. So there's my new second equation. Again, if that's messing with you, please multiply this by -3, put the bottom one there, and then add like terms together like we did for that last problem. Alright, -6 plus 6, that gives me 0. That's good, that's what I wanted to do. I want to get rid of that. There's no y term, so multiplying it by a number is still going to be 0 minus 1 will give me -1y. Here, if I multiply by -6, it gives me -12 plus 5, or -7z. And that's equal to, that's going to give me -30 plus 16, or -14. And now my first and second, if you will, steps are accomplished. I got the 1 in front of that x term, I got rid of these two x terms. My next goal is to get a 1 in front of one of these y terms, whichever one's easiest, or basically the same, just multiply by -1, and then get rid of this y term. Now you see this problem and you can easily see that everything's going to cancel. That's wonderful, but again, follow the process. So I'm going to copy the first equation down. Remember, yes, we are asked to solve the problem, but that's really not what we're trying to do. We're trying to get the process down. So trying to get a 1 in front means all I'm going to do is multiply it by -1, which gives me 1y, gives me +7z, and gives me +14. And then normally I would write down the third equation, and then the next step, get rid of the y in the third equation. I'm going to kind of combine those two steps together. So what would I do to these to get rid of the y? Well, I could multiply that by -1 and add it to that. So I'm going to say negative row 2, in other words, multiply by -1, and then add it to row 3. So that would make that +1 minus 1, or 0. That would make that +7 minus 7, or 0. And that would give me +14 minus 14, or 0. And so until you have the 1x, 1y, and then should be 1z, but if the z cancels, it's 0. Until you have that, you're not done. If you stop there and then you go through the rest of what I'm about to do, unfortunately, I'm going to deduct a half a point because you've not followed the correct process. You're close, but I need you to have that process down. It's said, I know I've said this probably 6 times already, but it's not necessarily solving and getting the right answer. It's getting this process down. Obviously, I do want you to get the right answer. All right, now if it's 0 equals 6, that would be awesome because we would be done. It's no solutions. When it's 0 equals 0, this is many solutions, but we're not going to say that. We are going to say that z is equal to z. And pretend like this is a number. If that said z was equal to 1, what would you do with it? You would take the 1, put it here, multiply, and then subtract to figure out what y is. Well, I do the same thing. I say that y plus 7z, basically just replace z with z, is equal to 14, and now solve. So it's kind of like I substituted it in there, even though it doesn't really change it. So what would I do to solve? Well, I'd have to subtract this. So subtract 7z, and now even though it's not a number, I do know what y is equal to. It's equal to -7z plus 14. Go back to the first equation. It's x plus, there is no y term, so I don't have to plug that in, 2 times z. Well, z is actually equal to z, is equal to 5. And now solve for x. So that means I have to subtract 2z, and there's what x is equal to. And then you're still going to write your answer like it's a three-dimensional point. You're going to say instead of x, you're going to say it's -2z plus 5, comma. Instead of y, you're going to say -7z plus 14, comma. And then instead of z, you write z. And there it is. It's kind of like we did in what we did in 7.2 when we said that there were many solutions on the line, y is equal to whatever. You can pick whatever number you want for z. So let's pretend that z was equal to 0. If that's true, I would have 5. If I put 0 in here, I would get 14. Of course, that would be 0. What I'm saying is that combination of numbers will make this true. If you plug those 3 numbers in for x, y, and z, all of those statements would be true. Let's say we thought z was equal to 1. It can be whatever number you want it to be. Let's say z is equal to 1. That would give me 5 minus 2, or 3. That would give me -7 and 14, or 7, 1. Those 3 numbers will also work here. So this is my final answer, and then whatever number I put in for z will give me a set of 3 numbers that will make the original problem work. Again, it takes a little time to get used to this, but you'll get the hang of it. Everyone usually does. All right, so now can I do a story problem? So, last problem we look at is this story problem. It says in the 2014 Women's NCAA Final Four championship game, the University of Connecticut defeated the University of Tennessee by a score of 70-61. The Huskies, which is the University of Connecticut, won by a score of scoring a combination of 2-point baskets, 3-point baskets, and 1-point free throws. The number of 2-point baskets was 2 more than the number of free throws. The number of free throws was 1 more than 2 times the number of 3-point baskets. What combination of scoring accounted for the University of Connecticut's 70 points? All right, so story problem, a lot of information. I've got to be able to dig out the information that I need. One thing I see is this. It says the Huskies won by scoring a combination of 2-point baskets, 3-point baskets, and 1-point baskets, or free throws. That means there are 3 types of scoring possible, which means I need 3 variables. And if I have 3 variables, that means I need 3 equations. So that's one thing I notice. So now they were very nice to tell us that the University of Connecticut scored 70 points. They said that they won. So looking at that score, I should be able to figure that they had the highest score. So even if they didn't say that they had scored the 70, I should be able to recognize that. So here's what most people are going to want to do for their first equation. And they're close, but they're a little off. They're going to want to say, okay, I've got x, I've got y, I've got z, and that's going to equal 70. And when you're thinking of the coin, if you go back to that coin problem that I keep referring to, it's close. that would be the number of, let's say, nickels, dimes, quarters, and that would be the number of coins. Well, this 70 points, that's the actual value of all the points. So I need to put value on each of these scores. So realistically what I want is I want to say that I have a 1-point basket, I have 2-point baskets, I have 3-point baskets, and I have a total of 70 points. That is representing a 3-point basket, and then I multiply it by 3 for the number of points. So if you thought this was your first equation, it's close. You're very, very close. But this is what you would want, because this does not represent, it's representing the value of the points, not the number of baskets. If they said that there were 70 baskets made, then yes, you would want that first equation. All right, so maybe possibly read through that a couple times and look at this, read through it, or look at this, so kind of make that connection. All right, so what else do I have here? Well, clearly I want to take a look at this thing next. It said the number of 2-point baskets. Now it's referring to baskets, so it actually wants X, Y, and Z, not 2Y, not 3Z, not X, because it's talking about baskets. So that's the X, Y, Z stuff. All right, it says the number of 2-point baskets, which is Y, was 2 more than the number of free throws, which was X. And this always kind of confuses people. So it's 2 more than the number of free throws. Well, here's free throws. It's 2 more than that, and that's what the 2-point baskets were. If you're not sure if you did that right, because I see a lot of times it'll be Y plus 2 equals X. If you're not sure, plug in a number for X. So for example, let's say X is 3. That means Y is 5. Does that make sense? If X is 3, is Y 2 bigger than that? It is. All right, so there's the second one. Then you want to take a look at the third one. So because I have 2 equations, doesn't matter that I don't have the third variable, it's okay. The number of free throws was 1 more than 2 times the number of 3-point baskets. So the number of free throws, which is X, is equal to 1 more than 2 times the number of 3-point baskets. Here's the number of 3-point baskets. It wants 2 times that, and then it wants 1 more than that. So those are the 3 equations that you would be looking for. Again, kind of difficult to read through the story problem and get that. If you need to, maybe rewind it and run through that again, or possibly, like I said, like I like doing, read through the story problem, look at what we have, read through the story problem, look at what we have, until you can kind of make that connection of where those numbers and everything is coming from. From here, we are trying to solve it. Now, if I was just solving it, not doing the row echelon form, this is what I would do. We're going to do the row echelon form, but this is what I would do if I was just solving. Notice that I know what y is equal to. I would actually just take this and make a substitution. I can figure out what z is and then make a substitution. And then I would have nothing but x's here and I could solve. That would be the quickest way to solve it. Since we are being asked to solve using row echelon form, or to kind of get used to that process, I'm going to go through the steps again. Now we're lucky because the first equation's already got 1x in it, so I don't have to do any changes here. I'm just going to copy down the 3 equations again and put it more in the standard form that we're used to, where the variables are all on the left. So if I subtract the y, put the constant on the right, this is what my second equation looks like. And then if I do the same thing to the third equation, I would have, looks like this. Alright, so that is what I would end up having if I put it in kind of your standard form. Now in terms of your solving, we get lucky. They all have 1's in front, so I don't have to do anything to that first equation. I want to get rid of these, so again, copy down that first equation. And then give yourself a note, even though it maybe looks obvious. I'm going to multiply the first equation by -1, add it to the second row. Now some of you might say, well, can I just subtract? Yes, you can, and there's nothing wrong with it, but when you're subtracting a negative, again, that's an easy mistake, getting a double negative. So try to think of it this way. If you say, nope, I want to think of it the other way, that's fine. Just make a note to the side like I'm doing here and tell me what you're doing. If you are taking row 2 minus row 1, fine. Alright, so multiply by -1. That would give me -1 plus 1, or 0. Would give me -2 minus 1, or -3y. Would give me -3 plus 0, so -3z. And would give me -70 minus 2, or -72. Again, if you want to show the work on the side, more than welcome to. Alright, same thing here. -1 plus 1 will give me 0 because I'm multiplying by negative 1. That'll become negative 2 plus 0, so negative 2y. Where else? Negative 3 minus 2, so negative 5z. And then negative 70 plus 1, or negative 69. Alright, so goal number 1, or 1/2, is accomplished. I got the 1 in front of the x, and then I got rid of the x's. My next goal should be to get a 1 in front of one of those y's. So, write down that first equation again. And remember, once you get the 1 in front of it, it basically will not change. Alright, now I want this to be a 1. Now could I divide everything by negative 3? Absolutely. They all are divisible by 3. Even if they're not, I could do that. It's just usually you don't want to do that unless they're all divisible by a number. What I would probably do is I would most likely multiply this by negative 1, which would make it positive 3, and then add to negative 2. That would give me a 1. You say, well, it's easier to divide by negative 3. Yes, it is in this particular problem, but that doesn't happen very often. Normally what you want to do is think of combinations of multiplying by something and adding it to this so that you can get 1. So hopefully that makes sense to you. So that's what I'm going to do, even though dividing by negative 3 would be easier. So I'm going to multiply by negative 1. That's row 2. I'm doing that too. And then I'm going to add it to row 3. So that would become a positive 3 minus 2, or 1. That would become a positive 3 minus 5, or minus 2z. That would become where am I at here? Oh, that would become a positive 72 minus 69, or 3. Alright, and then I'm just going to copy down the last equation. I'm going to bring my work up over here. Alright, so again, copy down the first equation. That will not change. Because we've got the 1 in front of the y term, the second equation will not change either, so I'll copy that one down. And then my only step left is I'm trying to get rid of that 2y, so I've got that stair-step pattern. So I'm going to multiply by positive 2 and then add it. So I'm going to multiply row 2 by positive 2, add it to row 3. So looking at this is going to give me positive 2 minus 2, or 0. It's going to give me negative 4 minus 5, or negative 9z. And then multiplying by positive 2 would give me 6 minus 69, or negative 63. And then instead of writing another step, I can go ahead and just divide that by negative 9 and say z is equal to 7. And then you can start back substituting and solving. So now if z is equal to 7, and I look at that middle equation, I have y minus 2 times 7 is equal to 3. Of course, that's 14, so I can negative 14, so I can add 14 to both sides to get y is equal to 17. And now plug back into the first equation. It's x plus 2 times y, which is 17, plus 3 times z, which is 7, is equal to 70. Now, a lot of you are going to want to just say it's x plus 34 plus 21 equals 70, and that's fine. I would prefer this just so that I can see where those numbers are coming from if for some reason you're doing something really out of order. But if you just gave me 34 and 21, I could follow that. Reason that I kind of like to see that is if you get a number that is not correct, it's a little easier to follow, but like I said, I can follow this just fine. Add those together, it looks like it's 55, is that? Go ahead and subtract 55, and you are going to end up with 15. And so now my answer is 15 free throws, 17 two-point baskets, and 7 three-point baskets. For this particular problem, I would say the majority of what you need to be able to do is make sure that you can get that set up. If you can get that set up, then it's just going through the Gaussian elimination or the row echelon form, which that will come to you as long as you keep practicing it. Don't get frustrated. It does take a little time. All right, that's homework help for day 1 of 7.3. Let me know if you need any extra help.